Okay, write and solve equations with variables on each side. We're actually going to go over to the launch real quick. I'm going to look this over. It says write and solve equations with variables on each side. Suppose an employee has two public transportation options to travel to work in the city. So each one has a different payment structure. If they use the subway, they will purchase a monthly pass that costs $21 and pay 80 cents per ride. To ride the bus, they will pay $2.30 per ride. Okay, so this right here for the bus says I have to pay $21. Then it says also 80 cents per ride. Okay, and then, sorry, I'm going to sneeze. This is just $2.30 per ride. Okay, how much, which one do you think is going to be the better, the better one to ride? I don't know. Let's talk about it. So, if X represents the number of rides taken in a month, so we're doing it in a month, then the subway option can be modeled with this expression. So they already gave you the expression. And the bus option can be modeled with this one. Okay? The equation, this one right here, represents when the cost of the two options is the same. So when it costs the exact same amount for the bus and when it costs the same amount as the train, or the subway. So when they're exactly the same. So in order to figure out how many rides in a month it would take for them to cost exactly the same, I would need to solve this equation. 21 plus 0.80 x equals $2.30 x. Now, I want to be able to get the variable by itself on one side. Remember, when we're solving equations, that's what we want to do. The whole point is to be able to have the variable all by itself. So that means that we have to eliminate it from one side of the equal sign. So I'm going to go like this. You know how we like to draw our line there. And in order to do that, I need to move this right here needs to move. I need to get it on the other side of the equal sign in order for me to have the variables on one side and the constants on the other side. So I'm actually going to subtract this to the other side. When I do that, I'm going to highlight it. All of this eliminates. Look at that. Those eliminate because 80 cents minus 80 cents is going to give me 0. So that eliminates each other. So now I'm left with 21 equals, let's see, I have an X. That would be 0. I'm going to borrow. And that's going to be 5, and that's going to be $1.50. So then, hopefully you put the decimal in the spot that it needs to be. This is multiplication. So the inverse operation of multiplication is division. So I'm going to divide both sides by $1.50. And when I divide by $1.50, that is going to get me 14. Now the question asks, it says, for how many rides in a month will the two transportation options cost the same? So 14 rides on, how do I want to write that? I don't want to use that terminology. On each type would cost the same. So if I rode the subway 14 times, that would cost the same as me riding the bus 14 times. Okay, so I'm actually going to change colors here. There we go. So let's go to this. It says, why is writing an equation a useful way to represent and solve a real world problem? English. Okay, let's go over here. So we're going to look at this. There we go. So the cost per person to bowl at a bowling alley A is $5.95 per game and includes the bowling shoe rental. Bowling alley B charges $4.45 per person per game plus $3 for the bowling shoe rental. Okay, so which one's going to be which? So let's think about it. If I played one game at bowling alley A, I would do $5.95. If I played 2 games, I would take $5.95 and multiply it by 2 because that would get me the price of a second game. If I did 3 times, that means I would multiply the $5.95 by 3. So that's going to tell me that this is going to be bowling alley A. Bowling alley B has this plus $3. This right here has a plus $3. Okay, we're going to come here. Okay, we want to know what's the cost for bowling alley A. So all we're going to do is take $5.95, multiply it by 1. That'll get me $5.95. Then I'm going to take $5.95 and I'm going to multiply it by 2. 5.95 times 2. And that's going to get me $11.90. And then I'm going to take $5.95 and I'm going to multiply it by 3. And I get $17.85. Then I'm going to take $5.95 and I'll multiply it. Oops, I didn't mean 3. I meant 4. So $5.95 times 4, and that's going to get me $23.80. And then $5.95, and I'm going to multiply it by 5. All I've done is substitute in the number of games. That's all I've done each time. And I would get $29.75. Okay, so now we'll go with, we'll go with green. So over here, I have $4.45. And that's times 1, and then we're going to add $3. So $4.45 plus 3 is going to get me $7.45. $4.45 times 2, because I substituted in the 2, that's going to get me $8.90 plus 3. So $11 and not that amount. $11.45. Then I'm going to take $4.45. I'm going to multiply it by 3 and add 3. So $4.45 times 3 is $13.35. And I'm going to add 3, so $16.35. Then I'm going to take $14.45 and I'm going to multiply it by 4 and add 3 cents. $14.45 times 4 will get me $17.80 plus 3. So that's $20.80. And last but not least, $4.45 times 5 plus 3. That'll get me $13.35 I did something wrong there. 1445 times 5. Yeah, that looks a little bit better there. Sorry about that. I hit the wrong button, obviously. Plus 3, and that's going to get 25. Okay, so all we did was substitute in a number for the variable, and then multiplied, and then added. So the question down here is, it's right here. There's the answer. It says solve the equation. So we're going to solve this equation right here. Okay, 5.95 G equals 4.45 G plus 3. Do you see that those are the exact same equations that we had for above? This is bowling alley A, and this is bowling alley B. What they're wanting to find when they set them equal to each other is how many, what does the solution mean in the context of the problem? So we set them equal to each other. So we want to know when the two bowling alleys equal each other. When the two bowling alleys equal each other. And Maya's growling at somebody. Okay? So we're going to actually solve this. So I'm going to subtract 445G, 445, and now we've got Sadie going. G, that's a 0, that's a 5, that's $1.50. Then we have 3. So I divide by $1.50 on both sides. Sorry, guys. So 3 divided by, I'm going to just do 1.5. I move my decimal over. 15 goes into that 2. So the number of games that they're exactly the same is 2. Now, what are some advantages of using the equation to solve the problem rather than the table? Because if we look up here at the table, we could have looked right here and said, oh, at 2 games, they're exactly the same. Now, personally, I would rather solve the equation most of the time, because sometimes you don't figure out when they equal each other until it's like 60 or 70 or whatever, and you have to keep plugging in numbers until you get that high up. Okay, so now we're going to go back over to our lesson right here. We already went over that, so let's look at this. It says, you can represent many real-world problems using equations, and most real-world problems you can. Okay? When you do a word problem or a real-world situation, it's really good to use a highlighter or underlining or something so that I would read through it first and then do some highlighting or underlining so that you can keep the two information or the information in the problem separate. So a music streaming website offers 2 plans. The first plan costs 99 cents per song plus an initial fee of $25. The second plan costs $1.50 per song plus an initial fee of $10. For how many songs will the 2 plans cost the same? So what I would do, I just read it. I just saw that there are 2 plans. And I'm going to do the first plan in one color. Cost 99 cents per song plus an initial fee of $25. And I'm going to change my color. And it says the second plan cost $1.50 per song plus an initial fee of $10. Now, before I do anything else, I want to look at some of these words. I'm not even looking this stuff down below yet. Do you see this word plus? What mathematical operation has to do with the word plus? that word right there means addition. So I'm going to be doing some addition. Okay, the other thing that you're going to see on this are these words right here. Initial fee. Initial fee is going to be your constant. Anytime you have an initial fee, and some of you may be saying, well, what does that mean? It means no matter what, I have to pay that amount of money, even if I don't do anything else, automatically. So think of it as this. You go to Magic Mountain, whether you have a pass or not, or Six Flags, whatever you want to call it. You have a pass or not, or you go to the fair. You pay that money to get into the place, but if you want to play those games or you want to get some food, you have to pay extra money. Okay? That paying to get into the place, that's your initial fee. Okay? That is a constant fee. Okay, so let's look down here what they have. So it gave you in words. Okay, then you have to figure out what variables. So you always, I'm going to do this color. You have to tell me what the variable is going to be, or whoever your teacher is, what the variable is going to be. If you look at this right here, it tells you that the variable is S and what the variable stands for. And yes, I should have picked a different color. Sorry about that. Okay, S is going to stand for the number of songs. So let's look at this. We said that the word plus, that means addition. If you look down here, we have addition. Then initial fee, right there, initial fee. That's our constant. Then it says per song. Per song. That means that this right here, over here, is our song. Our number of songs. Guess I should have done that in red also. Should be our number of songs. Okay, that is going to be our variable. So 99 cents per song, $1.50 per song. Okay. So let's come over here. Let's do some of these. So it says Green's Gym charges a one-time application fee. So the fact that it's one time, boys and girls, hold on just a second. What did we do for initial? Blue. Okay. One-time application. That's going to be like an initial fee. Okay. Oh, I'm supposed to read the problem first. Plus $30 per session for a personal trainer. Breakout Gym charges the annual fee of $250 plus $10 for each session with the trainer. So we do this again. Okay. Sorry. This says plus. And then we have $30 per session. Okay. Then the other gym says an annual fee of $250 plus $10 per session. So let's look at this. For how many sessions is the cost of two plans the same? Write then solve the equation and to represent this problem, check your solution. So the first thing you have to do always is you have to tell me what the variable is going to stand for. S represents the number of, well, what is it that's going, each what? Each session. Okay, each session. So that's going to stand for the number of sessions. Write an equation that models the cost of the two plans. Okay, so Green's Gym per session, right here, is $30 per session. So it's going to be $30 S. Breakout gem already tells you what it is per session, but it's missing how much it costs to initially be there. So 215 or 50. And then we solve the equation. So we want to have, I'm just trying to get this in here so I can draw the line. Okay. We want to get the variable to eliminate on this side. So we want to eliminate this right here. So we subtract it to the other side. And when we subtract it to the other side, I get 20s. On the right-hand side, because these two right here eliminated, I'm going to have 250. Then again, I still want my variable to be all by itself. I want it to be variable one side. I want it constant on the other side. I subtract 50. When I do that, I get 20s. The reason I don't like to use S, just so you know, is because my S looks like a 5. So 200. Divide both sides by 20, and I get 10. What does that 10 stand for? Well, S stood for number of sessions. So 10 stands for the cost is the same for 10 sessions with the personal trainer. Now, plug it back in and see if it works. So I'm going to replace the S with 10. 30 times 10 is 300. That would be $350 it cost for 10 sessions. Over here, I replace the S with 10. I get 100. Look at that. They both come out to the same amount at 10 sessions. Okay, so we're going to go down to this one. A container has 130 gallons of water and is being filled at a rate of a fourth a gallon each second. Another container has 200 gallons of water and is draining at a rate of 1/3 gallon each second. Can't talk today. So I'm going to reread this and I'm going to highlight. Okay. One of the containers is at 130 gallons of water and it has a rate of 1/4 gallon per second. Okay. Then we have another container at 200 gallons of water and is draining at a rate of a 1/3 rate. 1/3 gallon each second. Whew. So, where is it starting at? Okay, where is it starting at? This is where it starts for the first one. This is where it starts for the second one. They already have that amount of water in there. So those are my constants. So down here, it's looking for constants. So I have 130 as a constant here, 130 as a constant here, 130 as a constant here. This does not have 130 as a constant. Then I have 200 as a constant, 200 as a constant, 200 as a constant, 200 as a constant. So we've got that down. Then it says filled at a rate 1/4 gallons per second. Okay, so 1/4 is going to go with the 130. So I look here, 1/4 is with the 130 here. 1/4 is with the 130 here. Okay. Then I'm going to look at the other 1/3 is with the 200. So that means that this is not going to be it. 1/3. Okay. Now, it depends on which one is adding and subtracting. So let's go back up here and look at this. It says a container has 130 gallons of water and is being filled. So it's adding water. where this one says 200 gallons of water and is draining. So if you're filling water, you're adding water. If you're draining water, you're subtracting water. So 130 water plus 1/4, and then 200 minus. So that means that this is the one that's going to be used. Okay, so then it wants us to, so 130 plus 1/4 S equals 200 minus 1/3 S. Oh, those are those fractions that you guys hate so much. So I'm going to add 1/3 S. Add 1/3 S. Okay, so what color am I going to use? So the common denominator, I'm going to actually do it off to the side right here. 1/4 plus 1/3. Okay, I'm going to multiply these two together. So I'm going to multiply those together. So that would be 12. I'm going to multiply here. So that would be 3. Plus sign. I'm going to multiply here. That's 4. When I add that together on top, I get 7/12. So that means I'm going to have 130 plus 7/12 S equals 200. Subtract 130 from both sides. Get 7/12 S equals 70. Okay, I'm going to multiply 12 on both sides to get rid of that denominator that you guys don't like. 7S equals, there's a 0 and there's an 84. Divide by 7. Oh, it can come straight down here. Okay, so 7 goes into that 120 times. What does that mean? At 120 seconds, I guess I should put at 120 seconds, are they pools? Containers. The containers will have the same amount of water. Okay, so this next one. Ryan's Rentals charge $40 per day plus 25 cents per mile. Road Trips charges $25 per day plus 45 cents per mile. Okay, so again. Okay, Ryan's, $40. Okay, then Road Trips is here. Okay, so if I'm looking at the constants, oh, actually, I'm going to do this before. This word right here means plus, so I'm going to be adding. Okay, this is plus, we're going to be adding. Okay, now I noticed that these both have per day on them. They both say per day, they both say per mile. So let's look at what the rest of this says. For what number of miles is the daily cost? So it only wants 1 day. Okay, so we're only going to look at this right here being my constant and this right here being my constant. Okay, it's 1 day. So let's look at this. M is going to represent the number of, what are we talking about? Miles. Write an equation. So if I'm looking at Ryan's Rentals, It's $40 per day plus 25 cents per mile. So 25 cents per mile. Then it says road trips charges $25 per day plus 45 cents per mile. Well, it already has the 45 cents per mile, so I'm looking for how much it is for just one day. So for one day, it's $25. Okay? So then we're going to solve it. So it's down here. It's on the next page, and we're going to solve this. Okay? I want my variables to be on the same side of the equal sign. Normally, I pick the smaller one to move. And the smaller one to move this time happens to be the 0.25. So these two right here are going to eliminate. They're going to go bye-bye. Okay, they're going to eliminate. So I get 40 equals, bring the 25 straight down, and then this is going to be 0.20 m. Then I need to eliminate this right here, so I move it to the other side. When I subtract 25, that part goes to 0. So 40 minus 25 is going to get me 15. And then I bring down the 0.20 m. I divide both sides by 0.2 yeah. And when I do that, I get 75. So, in one day, if they go 75 miles, the cost will be exactly the same. Okay, so if I plug that back in, I replace the M with the 25 cents. 75. Nope, I did not say that. I apologize immensely. If I replace it with 75, sorry about that, I would get 1875. And then I add that together, and I get $58.75. Over here, I replace the M with 75. I think it's weird that they put the 45 cents in the parentheses instead of the 75 in the parentheses. But that's just me. 33.75. So we know that this is going to be 5.7. It's going to be 8, 58.75, and they equal each other. Okay, so on this next one, Annie is comparing the cost of to ship a package. One shipping company charges $7 for the first pound and 20 cents for each additional pound a package weighs. Another shipping company charges $5 for the first pound and 30 cents for each additional pound. So I know that both are, before I even talk about that, let's look at it. One shipping company charges this. The other shipping company charges this. Now, I know it doesn't say initial fee, but if you think about it, the first pound, okay, this is the first pound. This is our initial money for that one. That's our initial money for that one. So let's come down here and let's look. Does it have an initial? This has initial 7 and 5. 7 and 5. Initial of 7 and 5. This one does not. B does not. So that one's not going to be it. Then I have 20 cents for each additional pound. So that's going to be, I don't know what they're using P for pound. So for $7, it's got to have 20 cents next to it. This one, A, look at this. Is that 20 cents next to the 7? Nope. So that can't be it. 20 cents. Look at this. Right there. Awesome. Well, this is 20. Is 20 cents the same thing as 20? No, it's not. So that one won't work. So letter C is the one that we're going to use. So 7 plus 0.20p equals 5 plus 0.30p. So I need to solve this. Now I'm going to use the smaller one to move over. Okay, remember that's okay, I'll do that color, I don't care. Maybe not. I kind of like doing it in yellow, it's easier to see. Okay, so then I'm going to bring the 7 straight down, bring the 5 straight down. When I subtract these, I get 10 cents per pound. Then I'm going to subtract the 5 from both sides. When I subtract the 5 from both sides, these two eliminate each other. And I'm left with 2 equals 0.10p. And some people are going to look at this and they're going to divide and they're going to get the wrong answer. So let's look at this. This is 2 divided by 0.1. I'm going to move my decimal over 1 time. Move my decimal point over 1 time. 1 goes into 2 times. Bring down my 0. 1 goes into that. So the answer is actually 20 is equal to P. And what does that stand for? At 20 pounds, they cost the same. Okay. Suppose you are replacing the carpet of a living room where the length of the living room is 5 feet shorter than twice the width. A tack strip is placed around the perimeter of the room, which is equal to 5 times the width. If the carpet costs $2.99 a square foot, what is the total cost of the carpet in the living room? Okay, so let's read it again. You're replacing the carpet in the living room. Okay, so we need a living room. I need a living room. Okay. The length of the living room. It says right here. The length of the living room is 5 feet shorter than twice its width. Then it says a tack strip is placed around the perimeter. Well, before we even do that part, let's look at what we just said. It says the length of the living room is, that's an equal sign. So the length is 5 feet shorter. Well, what does shorter mean? Shorter means smaller or subtraction. Twice the width. So my length is going to be 2W minus 5. My width is going to be W. Okay, so first things first, I have to draw my picture and figure out the length and the width. Okay, so the next part says a tack strip is placed around the perimeter of the room. Which is equal to 5 times the width. Okay, so this, my brain is not working, I'm sorry. So, we need a tack strip around the room. Okay, we need a tack strip around the room. I wish I could show the video. Okay, so That's what that looks like. Really wish I could show that video so that you could see it. Okay. Okay, so first we need